Alright, we're doing a quick update video here. I wasn't even thinking of doing an update video, but I figured why not? It's been a bit of a while. I've started to scale the system up a bit, and I needed a high voltage DC power source that was more efficient than the boost converter, because the boost converter waste too much power in the process of stepping up DC voltage. So what we have going on here is a bifilar wound coil here. There's two conductors of equal length wound on this rod. One end is earth grounded. The other end is connected to two antennas. One down here, one in my window. And I wasn't even thinking of doing a video because of how messy things are, and because of all the things that were going on and how busy I was. But anyway, two conductor coil here. One leg is earth grounded, one leg is left open and connected to an antenna. The antenna leg end passes through a full bridge rectifier of 1N5819 diodes. The other AC end connects to the collector of the transistor, and I had to put 5 of these little transistors in parallel to handle what's going on because I scaled the system up. The system is voltage driven, not necessarily current driven. The system is run on very sharp, abrupt pulses, DC pulses. The more unidirectional you can make that pulse, the better. I'll list a very detailed video description. And these are the transistors I used. They are operating in avalanche mode. I put 5 in parallel. I think we're really on the right path now. I'll connect it and show you what it can do. So we're consuming 28.5 milliamps at... All the information will be in the video description, but this is just a big battery bank I built because I needed high voltage DC at the source without using a lossy boost converter. So anyway, what is that? I believe that's at 52 volts right here. No, 55. And anyway, this adjustable coil here can be moved to make the load brighter or dimmer. I think this is the path forward because I scaled up the system, and the transistors on the device have to be in avalanche mode for it to work. The rectifier installed between the collector of the transistor on the transmitter and the earth ground transformer coil here. This spot of the circuit provides you the voltage. This coil here provides you the current. And when you combine their outputs in parallel, you have a synergistic effect where you have voltage and current at the same time. So I wanted to show that. I can also tune this down. The insane efficiency of the system has stuck. We are consuming 18.4 milliamps at... Probably get this even better by adjusting it. I've also gotten this much more tuned before. Anyway, we're consuming 17.8 milliamps at 55 volts DC. Wireless power range is still insane. Loadless wireless power effects will still be present in the system. As long as you use germanium diodes. So again, I'll show you the really interesting thing. Again, I wasn't even thinking of making a video. Figured I'd get one out there. I'll show you our short circuit current of the system. It's been insanely busy working. Other things. Wasn't even really thinking of making a video, but figured I'd had to show the update of the progress. Full details. And in the community page on the YouTube channel. There we go. So our short circuit current is 0.5 amp at this resonant output. Our power consumption is only 33.8 milliamps, 34 milliamps at that input. It will slowly climb because the transistors are in avalanche mode. So our open circuit voltage here now is I believe the open circuit voltage is nearly equal to sometimes the system shuts off a lot. I have to touch it to start it. So the open circuit voltage is 47 volts DC. The short circuit current is 0.5 amp. Now if you want to actually use that and recharge your battery quickly, you have to impedance match that output with an LC network to your battery. So you would take a 12 volt 6 amp hour DC battery, you'd measure the resistance on it, and you would make an LC network that's impedance matched to your resonant output, and then it would deliver the full 0.5 amp to charge your battery very rapidly, and that's where the excess power would come from, while you maintain wireless power effects in the system. I wanted to get this quick video update out there. So to sum it up, what we have is we made a high voltage DC battery pack. Been doing a lot of experimenting. Things got messy. Went over all the Don Smith stuff again. Had AI helping with it too. And we made some grand discoveries. The system is primarily voltage driven, not necessarily current driven. The system is voltage driven with very abrupt unidirectional transient DC pulses, and I hope people are really soaking up this knowledge and taking it into consideration how it works. Staying connected back up. Hopefully there's not a problem. Good, we're lit. Anyway, I have a 280 ohm resistor here in series with a 10K potentiometer. Everything's carbon film. Has to be carbon film when you work with these resonant circuits. The full schematic for this and explanation will be on my YouTube community channel's post. To sum it up, what is occurring is we have the transistor here that actually sucks in power from the earth ground, the virtual earth ground, and we combine that DC output with this coil here that's wound per Tesla patent 336961. It has a center tap, and the two diodes get combined. There's a resonant capacitor there. The system is operating in a high voltage mode because if I touch it, I shut it off. I might have to max out my potentiometer to show this, but this little neon will light, showing that we're giving off high voltage, a high voltage resonant output. Now anyway, to sum up what is occurring again, we have a hyper efficient joule ringer circuit, earth grounded. The transistors running it are in avalanche mode. We have a 2-conductor coil here that is bifilar wound, open circuit. One wire phase is earth grounded. The other wire phase is left open. You can optionally connect that to an antenna. And the antenna end, or open end, that is not earth grounded, passes through a full bridge rectifier. The other end of that full bridge rectifier connects to the collector of your transmitter. That will give you the voltage for the resonant output, and your amperage will come from this coil that you wind per Tesla patent 336961. This coil has a center tap. You connect the two diode outputs, anode to anode, on each outer leg of the coil, and there's just a resonant capacitor there for fine tuning. I have to clean the system up, improve the output. This is the most efficient I've ever seen the system. The system will give you a nasty shock now. You have to be careful. It's almost looking like a Don Smith style system. and you'll have to forgive me the way I'm speaking. Just very tired, had a long day. Been going over a lot of work. Really going over a lot of work. And I wasn't even thinking of cranking out a video, but I figured, screw it, why not? You had to see the update. I scaled it up, took everyone's advice, and it got very efficient. The interesting thing is this output here seems to be volt ampere reactive, VAR, meaning the output seems equal to the input without the system being impedance matched. Now, I need to make a LC network in parallel with the resonant output here, which would be impedance matched to this battery to get the full half amp short circuit current to recharge it. And that's where the excess power would come from. Impedance matching is very important. You can easily figure that out with online calculators. That's the next step. Figure to give the update. I'll try and clean some crap around off the desk a little bit to show you what's going on. Take a step back, give you a good look under the desk. There's nothing. That's one of my plate antennas. My other plate antenna sits in my window up there. And the wireless power effects are phenomenal. They'll even be made manifest on random pieces of metal. This is the loadless wireless power effect that's being present. Very bright here on the virtual earth connection, because this system is in induction with the earth, sucking in power into the collector, and that gives us our voltage output. This coil gives us our amperage output. We combine the two, and we have resonant power. And it's obviously resonant power because you can see it igniting the neon. We have a high voltage field around the device. And now to make this useful, real useful, all I have to do is, I think this was the correct one. Open circuit voltage 47 volts DC, short circuit current about half an amp. Maybe it was this one. One of these meters blew. You guys can just fast forward stuff if you're getting annoyed. But yeah, our short circuit resonant output is half an amp DC, while we consume 36.7 milliamps from, I believe, our 55 volt DC source. I'm tapped into it halfway through. The ideal goal will be to tap into probably 100 volts DC through a much smaller DC source to drive the system. And it has to run in avalanche mode. For some reason, no other transistor will work for the system right now. It won't even turn on and oscillate. I have to use these transistors, or the system won't even turn on and oscillate in this type of efficient mode. And these are BC337B. Anyway, half an amp short circuit current. Open circuit voltage is 50 volt DC. So if we want the full half amp, we have to impedance match this output to our load, and that's it. That's the key to the secret. That's the secret to the system, the power output. So I don't know what else more there is to show or say. Gave a quick video update. YouTube community post will have the full schematic, full explanations, full schematic, full everything. I'll probably be selling these as well. Not sure on the price point yet. Try and quickly go over what's going on. The system is in resonance based off of some of Don Smith's work. See how sensitive it is to shutting on and off? But anyway, it's primarily voltage driven at an abrupt DC unidirectional pulse. It is transient driven, not necessarily current driven. You still need some current to trigger the switching of the transistor, but if it enters avalanche mode, you become hyper efficient. And if you make a special bifilar wound transformer coil, it's just two conductors wrapped side by side on a nickel zinc ferrite rod, 200 millimeter by 10 millimeter. The coil length is equal to the transmitter's coil, which would be 6.5 inches long. The L1 is 28 gauge wire, 6.5 inches in length, wrapped upon the rod centered. The L2 is 16 AWG wire, wrapped upon the rod centered in the opposite direction for a bucking configuration, which is the most efficient. Operating the system in low power mode that I was doing for a while in my older videos is very efficient, but scaling it up like people recommended and suggested seems to have unlocked a new area of very interesting research. The loadless wireless power effects still remain within the system, meaning you can tap virtually unlimited amount of lights off this system resonantly. And basically going over this coil is it's a bifilar wound coil, but you don't connect it in a bifilar way, meaning you don't take output A and connect it to output B on the coil, if you get what I'm saying. Like you wind this coil, it's two coils side by side, but you leave them both open. And they're well, technically each coil is half the length of the transmitter coil because there's two side by side and you needed the space. And when you wrap two coils side by side that are half the length in inches of the transmitter's the transmitter, it takes up the full length of the transmitter, if you get what I'm saying. And you ground one end. You ground one end of the wire. The other end remains open. That open end connects to a bridge rectifier. The AC side goes to your open end. The other AC side goes to the collector of the transmitter, or the outer L2 coil, the 16 gauge coil. This DC output will be your voltage. This Tesla style 336961 coil, the center tap is your negative. The outer ends get two diodes, 1N 5819s, connected together. This becomes your current, so you're combining voltage and current synergistically to get output. And to get this, and to take this output a step further and really use it, what we discovered is you have to impedance match this output that is lighting the LED with an additional LC network to recharge this battery that would then run an inverter. So you have to measure the resistance of this battery, and you would plug that calculation in based off the frequency of this thing, which is 250 kilohertz, I believe. You would impedance match it with an additional LC network, and you'd rapidly recharge the battery. You would get the full half amp of short circuit current you're reading at 50 volts DC delivered into that battery for rapid recharging. So that's what I wanted to say. That's what I wanted to sum it up. Wasn't even thinking of making a video, but I did. So that's that. Wireless power effects are still in the system. For those that doubt this system is running this, I'll disconnect it and the wireless power effects will go out. System is disconnected. Wireless power effects are out. In fact, I should probably feel these transistors if they're warm, because I am pushing them well past what they should be, because they're just little guys rated for 625 milliwatts each, and I had to put 5 in parallel when I scaled the voltage input up to handle 3 watts of power dissipation. So they seem fine. They're actually cool to the touch. And again, the system has to operate in avalanche mode. No other transistor seems to work for some reason. The system won't even turn on. I installed 1N5819 diodes, 3 of them, in the transmitter. It enhanced efficiency and improved the abrupt unidirectional switching in the transmitter, which enhanced the wireless power effects, along with the loadless wireless power effects. So that's that. Figured I'd get the video update out there, and take care, everyone. If you want to get in contact with me or purchase one of these or purchase one of the old systems we made, feel free to. Many improvements are around the corner. Feel free to like, comment, subscribe, join the channel, the Patreon, and again, really check out the YouTube community post page, because that's where all the detailed information is on this. That's where the full knowledge lies, in the YouTube channel community post. So thank you, everybody, and things are getting interesting. We can probably really start to move forward now. We'll see. So we have loadless wireless power present at an efficient input, driving a substantial power output load. And yeah, thank you, everybody. And if you want to see a good look at the battery pack before we end the video, I'll give you a good look at it. It's just kind of a big, bulky battery pack. 6 batteries in series. Not ideal at all, but I just wanted it for quick testing to scale up the system, because I was getting such good results, and it seems to have worked. So thank you, everybody.